Hello everyone and welcome to another Physics 210 online lab simulation walkthrough. Again, my name is Alec. Today we're going to be having a chat about Atwood's machine and going through some steps to, well, you'll be going through some steps eventually to calculate the gravitational constant of the Earth. Alright, so let's jump in. As a reminder, as always, please ensure that you have read through the other attached lab manual. Its theory section to learn about Atwood's machine and the physics behind it. And also, a quick note: I couldn't find a much more robust simulation than the one that I have down here. So the pulley that we'll use today has negligible mass, and the simulation that we're using for this lab uses an acceleration due to gravity of 10 meters per second, which is a rough but not awful approximation. So just keep all this in mind when you're doing your data analysis and such. Finally, I provided some equations for you because I make reference to them lower, so feel free to use these in any of your calculations and whatnot. Alright, so first what you're going to do is, using, this is very important, using Google Chrome, navigate over to this website to open up the simulation, and ignore any of these values in the upper left-hand corner here. And then, I know it's a bit weird, but we're going to need this Google Chrome extension called Pixel Zoomer in order to measure distances in this lab here. So go ahead and download that. And of course, if you have trouble with it or whatever, that's one of the reasons that I'm providing this video for you. And it makes measurements in pixels, so that's why I say quote distances here. And for the purposes of this lab, treat 1 pixel as equal to 1 centimeter. Again, a rough approximation, but we'll see what we can. But we're doing what we can. And of course, obviously, start your report. And for ease of use or reference, we're going to be labeling the blue mass A, and the red mass B. All right. So the first step, it says, is to use Pixel Zoomer to measure the number of pixels from the center of the pulley to the top of the mass A and record those results. So I'm going to use Pixel Zoomer here to do that. So the center of the pulley is kind of along this white line here. Measure all the way down, and you can see as I drag my cursor over, it's saying I just drew something that is a 1 by 129 pixel kind of snapshot. So the length of this rope in that case is about 130 pixels. So if we're treating pixels as exactly a 1-to-1 representation of centimeters, and then the length of this portion of the rope is 130 centimeters. And then for sake of argument, let's go ahead and do the other side as well. So I measure that out to be about 130 pixels, or in this case, centimeters as well. So ostensibly, the length from the center of this pulley to the mass is about 130 centimeters, or 1.3 meters. All right, moving on. It says to set mass A to 0.1 kilograms and set mass B to 0.2 kilograms, so I'm going to do that. 0.1 and 0.2. You'll see that they shrink in size and grow in size as we adjust the masses here. Next step is to have a stopwatch ready, which I'm going to have on my phone, so I'm just going to need you to trust me that that I'm giving you the proper time measurements in this video. Or you can, of course, use the YouTube timestamps to do so, but they're going to be shorter timestamps this time around, so it might be a little more difficult. Or, if you'd like to play along at home, you can use your own stopwatch to record the times. That would be fun as well. So it says to press play and record the time it takes for the masses to stop moving. So, they're going to start moving, and then eventually they're going to stop moving. And it says that this will happen in the first case when mass A touches the pulley. So let's go ahead and do that. I'll hit play, and then I'll start the timer on phone at the same time. Okay, so I got about 2.11 seconds. So go ahead and record that in some kind of data sheet that you're taking. And then it says to repeat step 4 additional times. This is going to reduce our error in the timing. So again, the first measurement was 2.11 seconds, and we're going to go ahead and restart and do it again. Okay, I got 2.07 seconds for that one. For the third trial, I got 2.04 seconds for that one. For the fourth trial, 2.03 seconds. And for the last trial, 2.11 seconds. So what you're going to do then with those measurements is find the average time of those five trials, and then calculate the uncertainty, knowing that the average human reaction time is about 0.2 seconds. If you're a hockey goalie, then you're probably significantly better than that. But for us average Joes, it's about 0.2 seconds. So your uncertainty in timing is somewhere close to plus or minus 0.2 seconds. And then, using that data, you're going to calculate the acceleration using equation 1, which again is provided for you in the lab manual up here. And of course here, h is going to be the distance that you measured earlier from mass A to the pulley, because ostensibly mass A is moving that distance up to about the center of the pulley there. It's a rough estimate, but you know, we're doing what we can. All right, now what it says to do. Sorry, I skipped down a little bit. All right, now what it says to do, you know, calculate the acceleration using equation 1, and then calculate the uncertainty on A using propagation of errors. I will allow you to do that on your own time. And of course, remember that t squared is equal to t times t, so that is going to affect your propagation of errors. And now it says to repeat steps 1 through 8 using each of the following masses, all of these. So we're going to leave mass A fixed, and we're going to adjust mass B to change that mass difference, right? And that will, of course, change our acceleration. Okay, so let's go ahead and do that. This time what I'm going to do is, oh, actually, I just realized we don't actually need to repeat steps all the way 1 through 8. We just need to repeat steps, let's see, essentially 4 through 8. So let's do that. I will adjust that in the lab manual once I post this video. All right, so we're going to switch mass B to 0.3 kilograms, and I will walk through all of the different, I will walk through all the 5 trials with you, so let me just go ahead and run through those real quick. All right, I got a time of about 1.8 seconds for that. And then for trial 2, about 1.72. About 1.76 for trial 3. And then for trial 4, about 1.69. And for trial 5, about 1.68. All right, so go ahead and record those times, and I'm going to go ahead and move on to the next mass here, which is 0.4. And we're going to go ahead and start. All right, about 1.5 seconds there. About 1.08 seconds for trial 2. About 1.58 seconds for trial 3. About 1.61 seconds for trial 4. And about 1.52 seconds for trial 5. Now we're going to shift the mass up to 0.5, and I'm going to hit start. All right, so I got about 1.54 seconds for that one. Got about 1.43 seconds for trial 2, and for trial 3, 1.45. For trial 4, 1.46. And for trial 5, about 1.41. And the last one, we're setting this mass to 0.6. And I'll hit reset here, and we'll go ahead and start. All right, so I got about 1.4, about 1.36 for trial 2, about 1.48 for trial 3, 1.37 for trial 4, and 1.32 for trial 5. So that should be all the data you need for this lab. Go ahead and from there, using the data that you just took, obviously if you need to watch this video once or twice more to get all of that, feel free. Go ahead and run through sections 4 and 5 in the lab manual. It's a bit lengthy, but it's mostly just, you know, creating graphs and things like that. So hopefully this video was of some help to you. If you have any questions or need any help, go ahead and email me. Otherwise, the actual procedure for this lab was relatively simple. It was just kind of watching blocks fall. So, all right, thanks a lot, everyone. Have a good day. Bye.